When it comes to metallic coatings, appearance can be deceiving. A surface may look smooth, uniform, and defect-free, but still fail under real-world conditions. This metal coating looks perfect, but under stress, it can fail instantly. And when that happens, you're looking at corrosion, product failure, and serious costs. So how do manufacturers catch this before it's too late? There's a standard used across industries that can expose weak coatings in minutes without complex equipment. It's called ASTM B571. And once you understand how it works, you'll see why it's such an important part of quality control. Here's the problem. A coating can look flawless on the surface, but still have poor adhesion underneath. That means the bond between the coating and the base metal is weak. And once that bond fails, everything else follows. You get peeling, cracking, blistering, and eventually complete coating failure. What makes this especially risky is that you often can't see it coming. That's exactly what ASTM B571 is designed to detect. ASTM B571 is a standard for testing how well a metallic coating sticks to its base material. But instead of relying on a single test, it provides several simple methods that apply stress to the coating, so you can see if it holds or fails. And unlike complex lab testing, these methods are fast, practical, and ideal for real production environments. Now here's why this matters. Metallic coatings aren't just about appearance. They're used for corrosion resistance, wear protection, electrical performance, and durability. If adhesion fails, all of that disappears. In automotive parts, it can lead to early rust. In electronics, it can affect conductivity. In aerospace, it can even become a safety issue. That's why adhesion testing is critical. So how does ASTM B571 actually work? It uses multiple test methods, each designed to reveal weak adhesion in a different way. First, the bend test. You bend the coated material to a certain angle. If the coating cracks, peels, or separates, it indicates poor adhesion. Next is the tape test. You apply adhesive tape to the surface and pull it off. If any coating comes off with it, that's a clear sign the bond is weak. Then there's burnishing. This involves rubbing the coating under pressure. Weak areas start to show quickly, even if they weren't visible before. Another important method is thermal shock testing. The coating is exposed to rapid temperature changes, heating and then cooling. If it blisters or separates, it won't survive real-world conditions. There are also other methods like filing, scribing, and impact testing, but they all follow the same principle: apply stress and observe whether the coating survives. And here's something important. None of these tests require complex or expensive equipment. That's one of the reasons ASTM B571 is so widely used. In real manufacturing, this standard is used for quality control, process validation, and troubleshooting. Sometimes parts can't be tested directly due to their shape or size. In those cases, manufacturers use test panels that go through the same coating process. This ensures the test results still reflect actual production conditions. Now, it's important to understand one limitation. ASTM B571 is qualitative. It doesn't give you a numerical value for adhesion strength. Instead, it shows you visible results, whether the coating passes or fails. That makes it perfect for detecting problems quickly, but not for measuring exact strength. Still, for most production environments, that's exactly what's needed. A fast, reliable way to catch failures before they become costly issues. So next time you see a flawless metallic coating, remember this. Looks don't guarantee performance, because in the real world, a coating is only as good as its ability to stay attached, and ASTM B571 exists to make sure it does. If you found this helpful, make sure to subscribe for more content on engineering, coatings, and manufacturing, and check out the next video to learn about other important coating standards.